just make sure that I can hear you. All right, so again, our plan for today is to finish the second half of our rubric. And then once we complete that, we'll do some questions and then figure out and assess your weaknesses and reinforce that information so that when you get to your test, you will feel a lot more confident about the questions that's being asked. Okay. All right, so let's talk about how atoms form. Okay, so when we're talking about how atoms form, we're essentially, one, I'm gonna take a step back and say, you know, an ion is a charged particle, right?
Yeah.
Yeah. An ion is an atom, essentially, that is charged, right? If you know, atoms have the ability to lose or gain electrons. I think this is something we've talked about. And pretty much today, you will see how everything that we've discussed thus far connects and integrates into what we're going to be talking about today, right? So in the periodic table, we talked about the different groups, right? We talked about the valence electrons, we've talked about Lewis dot structures, we've talked about Bohr model. All those things kind of lead to this point of like our atoms forming ions, right? Yeah. And so as it relates to our periodic table, you know, from group A all the way to group 7, right? Group A is going to have what? 1 valence electron. Group 2 is going to have 2 valence electron, right? So essentially, if an atom gains an electron, it will have a negative charge, right? So what I want you to notice here is that there's this reciprocal relationship going on, right? Gaining means negative, and losing means it's becoming a cation, right?
Yeah.
Does that make sense?
Yeah, that makes sense.
Okay, so, okay, all right. So as long as that is clear, and then we'll essentially relate all of that to the periodic table once we get to that slide. Okay, all right, so now, why do ions form, right? And essentially, right, the reason why, and we've talked about this before, they form because atoms wants to be stable, right? They want to reach that full octet. They want to reach that full 8 valence electrons, right? That's one way that they will become stable, right? And so if they want to reach this stability, they will either follow that Bohr model. Remember when we talked about that, when we said that it can either go to its ground state or its excited state, right? And depending on whether they will reach an octet, they will move down, right? One level, one orbital, because that orbital already has an 8, or they will move up depending on if that specific orbital has enough electrons. Does that make sense?
Yeah, that makes sense.
Okay, so again, the goal here and the reason why atoms form ion is because they want to be stable. Okay, keep that in mind, right? But how do you know if an ion will gain or lose an electron? To form an ion, right? So like I said earlier, atoms are going to gain electrons if their valence shell is mostly full, right? So I'll show you this in the periodic table in a little bit, and then vice versa, right? Atoms will lose if their valence shell is mostly empty. And so, for example, our valence electron, right? Here you have group A. Can you see my mouse?
Yeah, I can.
Right, so here you have group A, right? And this one is going to hold what? 1 valence electron, right? And the thing about this is that, remember I said, if you lose, you become positive. If you gain, you become negative, right? So there's that what I said, the reciprocal kind of relationship there, right? And so here, because you have group A, right, that has one valence electrons, it's not going to sit here and say, like, for example, let me just show you in writing, right? So what's going to happen here? Like I said, let's just, for example, have sodium, right? Na, right, has one valence electron right here, right? And let's say that Na has this, orbital, right?
Yeah.
Right, and Na is going to have this one lone valence electron that's going to be on its side, right? Here, right? And then the orbital before that is pretty much what they call stable, right? It has the orbital before that reach an octet. So what it's going to do, instead of like, attracting 8 more electrons or valence electron, what it's going to do, it's going to give that away. It's going to lose it, right? So if it loses, it becomes more what? A positive +1, right? So
Yeah.
this becomes a cation. Why? Because if it loses 1 and becomes a cation, that means that the orbital before that is what? Stable, right?
Yeah.
Like I said, the goal is to be stable. So it's going to freely want to lose that electron. Does that make sense?
Yeah.
Okay, and that's pretty much the same story for all of group A, right? For all the alkali metals, right? And then it's going to be the same story for group 2A, right? And the
Yeah.
thing about this whole situation is that anytime you lose or gain an electron, it causes or uses a lot of energy, right? And so for group A, because it's only losing 1, it doesn't cost that much energy, right? So it's gonna just give it away. Like it's easy for group A and the second column to lose that electron because it doesn't take much energy, right? So essentially what you see is you will see what sodium +1, right? And I know you've seen calcium 2+, right? And that's because it's giving away those 2 electrons to make sure that they essentially that the orbital below that they reach that stability, right? So these are essentially what you would say people that have enough money and they're willing to give it away, right?
Yeah.
And then in addition to that, right? So we said that here, which is our group 8, right? So one thing we have to keep in mind about this whole situation is that you have to make sure you know how to number each column of the periodic table, right? So you have 1, you have 2, you have 3, you have 4, you have 5, you have 6, you have 7, you have 8. And remember what we said, when you have 8 valence electron, you are stable, right?
Mhm.
So the 8th group is not really going to participate in anything, right? Because
Yeah.
why is it not going to participate in anything?
Because it has is it because it has an even number of electrons, right?
Right. It's even. And what does that mean when it's even?
It means it doesn't have to lose one of its electrons, right?
Well, it's not necessarily because it's even, because if that was the statement that you're making, you can make an argument that 4 and 6 is even. But just because group 4 and 6 is even, does that group mean that it's stable? What is the real goal?
To get them all paired up, right?
To get them all paired up, yes, but paired up to reach what?
To reach I don't really know. To reach the
The goal is what?
it's to be stable, right? So
Right. And what stability means what?
um to basically um not have to lose or gain an extra electron and then just oh, it's kind of hard to explain.
Well, you're along the right line. I feel like you are explaining the definition of what being stable means, which is essentially like reaching an octet, right? Stability. So
Yeah.
if you were asked this, right? No, right? Know that what I'm trying to say here is that, it's not about the fact that it's even, but it's the fact that it has reached an octet, right? And an octet means, right, every atom wants 8 electrons, right? And that's what stability means, right? So the reason why group 8 doesn't need to participate in anything, because why? It already has 8, right? And the reason why everything else has to either share or pair, right, is because what? They are trying to reach 8. They're trying to reach that stability level. That's the reason why sodium loses 1 electron, because the orbital below that has 8. Does that make sense?
Yeah, that makes more sense.
Okay. So again, what's the goal of an atom here?
To reach an octet,
Okay. And octet means what?
it means um that there's 8 little like what's that 8 electrons, right?
Yes, there's 8 electrons. That's correct. Okay, good. I just wanted to make sure that I bring that home for you, because that's a really important concept. Sorry, 1 second. I'm trying to make notes on my iPad on this, and it just kicked me out of the iPad. I'm not sure why. Okay, so again, stability is, let me just write this down for you. Stability is octet, right? And octet means 8 valence electrons. Okay, remember that. And then the reason why group 8 is pretty much not participating in anything, because it has already reached that stability level, right? And like I said again, group 1 and 2 are going to willingly want to lose those electrons, making them 2 plus, right? Because the orbital before that is going to have 8 electrons, right? And again, this is relating to what? The Bohr model, right? We said last week that the Bohr model has this orbital, right? And depending on the way that an element or an atom loses electron, it's either going to move up or down, right? Right? Where it's either going to emit or absorb, right? Energy, right? Photons, right? Right? So
Yeah.
in this case, what's happening is that in group A, sodium has 1, right? And so it's going to do what? It's going to want to go back 1, right? Which means what? It's going to emit, right? And it's going to release energy, right?
Yeah.
Compared to if it was going up, right? Which is going to absorb, right? Which means that it's going to absorb high energy, right?
Yeah.
So I'm just trying to make sure we make that connection from the Bohr model to, making sure that what essentially forms these charges when it comes to atoms either becoming a cation, right? A cation is what we have in sodium and our calcium 2 plus here, which is part of either group 1 or A. We have a cation, then we have our anion, right? And I'm going to talk about the anion in a little bit, right? And an anion in this case, right, we said here it's going to lose, right? Because it's gonna want to give it away, right? Because the orbital below that, it's going to be at its octet, right? Now, here, when we're talking about our, group 6 and a group 7 here, right? We're talking about a different situation here. This is a situation where it's closer to 8, right? So what is it going to do? Are we going to want to lose, or are we going to want to gain electrons here?
You're going to want to gain electrons.
Right. So what's happening here is that you have what? An orbital that has, for example, let's say chlorine, right? Chlorine, we have what? 1, 2, 3, 4, 5, 6, 7, right? We have 7 valence electrons, right? So this is not going to want to lose an electron. This is going to want to gain, right? I want to be able to gain 1 electron because, again, that's going to what? That's going to spend less energy, right? You were to take out 7 electrons, that's going to take a lot more energy, right?
Yeah.
Right. So here, what's happening is what? It's going to want to gain 1, right? Because that causes less energy, right? And so when it gains, right? When it gains, chlorine becomes what? Right? So chlorine is going to become an anion, right? It's going to have what? It's going to have that -1 that it gains, right?
Yeah.
Right? Does that make sense? And it's going to be the same for group 6, right? We often see a chlorine -1 or an oxygen -2, right? Because what? It's easier to gain 2 or 1 electrons to reach a final octet, right? So that's the point there. So here your oxygen is going to what? 2 minus, right? For example,
Yeah.
which is going to essentially want to gain electron to reach, again, our goal of reaching a final octet.
Yeah.
Right? Okay. So, and then just to kind of bring this home, and then I'm sure this is something that you've noticed as well, is that, we often see sodium, sorry. Oh, my allergies. I'm sorry. Okay, that was false alarm. Don't you just hate false alarm?
Yeah.
Okay. Okay. So again, like I was saying, sodium in that group 1A and group 2, we mostly see those as cations, right? So you can kind of use that as like, something that you can just keep in mind, that atoms that are going to be in your group 1A and B are going to be your most often seen cations, right? And your most often seen anion are going to be what? Your chlorine, your oxygen, your fluorine, right? We even often see what? NaCl together, right? Because what? Those are the most often ones that are either, needing to either share or give away electrons, right? Sodium wants to give away, and then chlorine wants to take, right? So those two obviously are going to partner up, right?
Yeah.
Right. And so, I mean, the main point that I'm trying to make here is to kind of bring this home for you, that, and to make it easier in terms of the concept that, sure, majority of what we see for cations and anions are going to be your very far left and your very far right for cations, and then for your anions. And then here, when you reach this group 3, 4, 5, right? Those are the ones that you see less, right? You see them less. Why? Because it takes a lot more energy to try to either gain or lose 2 to 3 or 4 electrons, right? It takes a lot more energy to try to form this stability that is going to that group 3, 4, or 5 is trying to reach, right? So not that it's saying that it's not possible, right? Because we see what carbon dioxide, carbon and oxygen forming together. But my only main point is that it's going to take more energy for that to happen. Why? For example, carbon dioxide, in order to make sure that that is in its full stable state, guess what? It needs 2 oxygen, right?
Yeah.
Right. So that, like I said, the only main point here that I'm trying to make is that that's why the concept and the idea of reaching stability and having an octet is important. That relates to the Bohr model when, you know, electrons are moving up and down the orbitals, whether it's in its excited states, which is absorbing high photon energy, right? Whether it's going to its ground state, which is what, reaching and releasing energy, which means that it's emitting photon energy, right? Or whether it's writing or drawing the Lewis dot structures that we've been talking about, right? You can see here by just pretty much, you know, me drawing out this chlorine gaining 1 electron, right? To have its chlorine -1 on anion. You know, it's easier to kind of represent that by using the Lewis dot structure, right?
Yeah.
Does that make sense?
Yeah, that makes sense.
Okay. Hopefully I didn't talk your ear out here. Okay, so that was the main point of that. Do you have any questions, comments, concerns?
I have no questions.
All right, so let's move on. And then, like, when we're talking about determining the charge of something, right? This is, you know, you can almost make an assumption, right? You know, if you are running out of time and you're in an exam and you see anything from group 1, from group 2, 3, 4, 5, you know, and so on, this is the anion, or these are the charges that are more likely, that you will more likely see, right? Anything on group A is going to have that +1 because it's losing 1, right? Anything in group B is going to be +2 because it's losing 2. Anything in group 7 is going to be -1, -2 in group 6, right? Because it's gaining, right? Anything in group, I would say 5 is going to be -3, right? Anything in group 4 is going to be negative or +4. And then 3 is +3 because it's losing 3. Right? So this table here hopefully helps you keep track of these charges. And you know, if you look at this often, you're often just memorize all these anions and cations that are mostly tested. So this is your mostly tested anion and cations. Yes, makes sense?
Yeah, it makes sense.
All right. So now we're going to talk about why metals tend to lose electrons. And the reason that is all transition metals lose electrons when they reach, when they react and so form positive ions. So one thing you have to know about these transition metals is that they're going to have positive ions, right? Which means what? Just like we said, positive means what? They're losing, right?
Yeah.
Right. So one of the most popular transition metal ions are going to be your silver here. Silver is going to be Ag plus, right? That means it lost 1, right? Zinc is only going to form that zinc 2 plus, which means what? That it's going to, that it lost 2, right?
Yeah.
Right. And so another thing that is kind of cool to notice here is that you know, your silver, those are, again, you know, if you're going to memorize anything here, memorize those most likely tested atoms, which, like, for example, here, your silver and your zinc, right? So remember that. And then I think another thing that we talked about when we kind of discussed, naming compounds, right? We said that when we're naming transition metals, we're using what? We're using Roman numerals, right? And the Roman numerals are going to what? It's going to essentially represent the ions that are involved with them. So iron 3 means it's iron 3 plus, iron 2 is going to be your iron 2 plus, your copper 2 is going to be your copper 2 plus, and so on, right? So keep that in mind too, in terms of how we write out our transition metals, right? Which is something, again, we've talked about before. Right? Make sense?
Yeah, it makes sense.
Okay, any questions?
No questions.
Is this any at all similar to majority of the stuff you're learning in class?
Yeah.
Okay, so we're gonna do some quizzes from our lessons from last week so that we can practice and then figure out what areas we need to work on and reinforce, okay? Let's do some Bohr model questions. And if possible, share your screen with me. I'm gonna stop sharing now.
Okay.
Okay, you ready?
Yeah.
Let's see. Hopefully it's not too hard. Okay, here is the link. This one is 15 questions on Bohr model, okay?
Mhm.
All right. Let's do it.
What is the name of this element? Am I able to use a periodic table? Ooh, that's 1, 2, 3, 4, 5, 6. I think that is. I'm gonna say. I think that's hydrogen. Probably wrong. I'm gonna leave this
Okay. So what happened here?
up. I don't know. I think I didn't get the periodic table up in time to kind of help me. So then I kind of struggled at the last second. So then I think I counted. I don't remember what I was doing exactly, but
Okay. You can also, click the picture if you want to make it bigger, if you
okay.
can't see. And another thing is that, remember, like I said, it's important to look at the orbitals here, right? And
Yeah.
like I said, the goal of an atom is to do what? To reach an octet of 8 valence
Yeah.
electrons, right? So here you can see that at that final orbital, it has what? 8 electrons, which means that it's possible that it's one of the what?
One of the ones from here. the 8th orbital.
Right, and that is what we call what?
That's the what is it called? The oh, I literally just had it in my head and then I lost it. It's the not it's not neutral, but it's the what is it called? I know it's not neutral. It's I don't remember exactly.
So it's called the noble gases, right?
No, oh, the noble gas. Okay,
Right. Okay. So let's do the next question and see how that one goes.
okay. This element. So 7, 1, 2, 3, 8. Is it? Wait. Is it right? 1, 2, 3, 4, 5, 8. So that's so I think it's it's me. Okay.
Woohoo.
That's number. Is that
Woohoo.
Okay.
This is good review, okay?
yeah? Let's tell number. It's 22. It's 20. Yeah. Okay.
Good job.
What group does this element belong to?
Ah, yeah. Okay, tell me what happened here.
It's atomic number 3, right? I'm gonna assume one. Let's say tell off. It's 1, 2, 3. So that's number 3.
The question here is asking what group does this element belong to?
Yeah.
And so the first orbital here is giving us 2 in the inside, and then the outer orbital has 1 valence electron. When you have 1 valence electron, what is that supposed to mean?
It's supposed to mean that does it like cancel one of these out? I'm assuming not cancel it out, but like
Not necessarily, but it just means, remember we talked about it in the periodic table. If there is 1 valence electron, This means that you are essentially like this orbital, this electron is gonna likely want to be lost, right? This is
Yeah.
part of your what? Your group 1A, right? Your alkali metals, because there's only one here, right? And depending on what column or group you are, you will have 1, 2, 3, 4, 5, 6, 7 valence electrons, right? And this is showing you that the outer shell, right, has one valence electron,
Mhm.
right? So when you're looking at what group something is in, right? If this was the outer shell, if this was the only, if there this orbital didn't exist here, right? If this wasn't here and it showed D2, what group would that be?
That would be the the earth metals.
Right, right. So always keep an eye on the outer shell, like that final shell, that very outer one, if it has, and then also that very outer one, and then count how many valence electron is in there, right? So keep an eye on that. Like, just like you mentioned, right? Here, the outer shell is showing that one electron, which suggests that it's in group 1, alkali metals. And if that outer shell didn't exist and you have that 2 valence electrons, then it's going to be what? Group 2, which is your alkali earth metals, right? Does that make sense? Makes more sense?
Yeah, that makes more sense.
Okay, cool.
How many valence electrons? So there's, so it's inner. It's 5. Yeah, it's that much.
Awesome.
Okay. What's a valence electron? Outermost. What's vertical horizontal? Vertical is. Ooh. Yeah. All right. I should remember this.
Good job.
Its energy has a maximum of how many electrons? I think that's. It's a 2 and 2. Yeah, 2.
Good job.
Okay, what is this element? Um, where is it? This one. Yeah, that's me. Okay. How many valence electrons? 4. How many group elements does this belong to? How many? What group does this element belong to? So that's one. Wait,
This
what?
was literally a repeat question.
Oh, okay. I see what okay, now I see what I did. I counted the inside instead of the outside.
I see. Okay.
Okay, yeah. I gotta remember that.
I'm gonna let you off the hook on this one.
Alright, I should have remembered that.
Good job.
Auto represents me.
Good job. Great work.
Alright, I did way better than I thought I would actually have done. Because it's been a while since we've done one of these.
Yes. But that's the point, right? We wanna we're trying to practice so that we can prepare you for your test that's coming next week, right?
Yeah, next week. I think it's on the 17th. I think that's
So it's next week's.
yeah.
So and then now we're gonna do some let's do some Lewis dot structures, and then we'll do the different stages and fuel of the star cycle.
Okay. Yeah.
Okay. Okay, so this is gonna be let's do oh, what happened? Okay, let me share the quiz link with you.
Mhm.
My internet is slowing down here. One second. Why is it happening? One second. Lewis dots. Okay, here we go. Um, okay. This one. Okay, so this one has 16 questions. That's not yet. Okay, here we go. Is it loading for you?
Yes.
Cool. Let's go.
Jesus, running.